You're listening to Now I've Heard Everything, interviews from the 80s, 90s, and 2000s with voices from the past.
It is the search that enlarges and expands your, visions of what's possible in your mind and so on, irrespective of whether at the end you have a yes or no answer.
Astrophysicist Mario Livio, today on Now I've Heard Everything. I'm Bill Thompson. All right, well, today we're going to be talking about mathematics, but don't let your eyes glaze over because there are no formulas to memorize, no equations to solve, and there will be no quiz at the end. In fact, we're really not even all that worried about the answers as much as we are with asking the questions, says astrophysicist Mario Livio. His 2009 book, Is God a Mathematician?, asks all the big questions and helps explain why and how mathematics explains everything in the universe, or how it doesn't. That's one of the big questions. So here now, my 2009 interview with Mario Livio.
I didn't find your book on the religion shelf in the bookstore, though.
I certainly hope you... Well, I have nothing against it being on the religion shelf as well, but the book is really not about God. It is about how come mathematics is as powerful as it is in terms of explaining the universe.
The essential question of the book that you're exploring is mathematics an invention or something that human beings are gradually discovering? Right.
So there are two parts really to this question. I mean, one is mathematics a discovery or an invention? And the other is, what is the reason for its incredible effectiveness? Mm-hmm. That's right.
Well, you do really open my eyes in this book to the whole broadest possible range of ways that we use mathematics every day without even realizing that we're using it. And how could this be a happenstance? This has to have been ordered somehow.
Right. So in particular, I mean, I think that some of the most amazing instances of the use of mathematics are those cases where mathematicians formulated something with absolutely no application whatsoever in mind, and then decades or sometimes centuries later, suddenly that branch of mathematics turned out to be precisely the tool needed to explain something in the universe.
And the explanations are sometimes startlingly elegant with what, as you said, maybe they came up with years or centuries earlier. This can't be accidental, can it?
So I don't think it is actually accidental at many levels. I mean, there are several effects that help mathematics in this way. One is what I would call evolution and natural selection of ideas, which means that the things that don't work, we don't talk about that much, and we tend to talk more about those theories that do work. That's one thing. The other thing is that the mathematics that we use to explain phenomena are not chosen arbitrarily. We do not decide, for example, to count the amount of water that you have if you put drops of water into a vase by using the natural numbers. We use other invented concepts like the weight of the water or the volume or something like this and so on. So this is just a simple example for the fact that we're actually tailoring at some level the mathematics that we use to the problem at hand.
It depends on metaphors then, does it not?
It depends a lot on metaphors, and the cognitive scientists in particular like to say that almost everything we think about is in way of metaphors, and it is certainly true to a large extent. So yes, indeed, we use metaphors when we try to model something.
But as sophisticated as our metaphors can be, at times it sometimes feels like we are just watching the shadows on the cave wall.
That's right, like Plato, of course, used to say. Yes, so sometimes you're right. I mean, Plato said this about reality in general, that all the reality that we see is just like shadows on the cave wall, while there is a reality out there that we cannot really perceive. The people called Platonists say that about mathematics, that, it exists somewhere in this Platonic world of mathematical forms, and we're merely discovering it. I think at the end of the day, mathematics is an intricate combination of inventions and discoveries.
Does that mean there is only one mathematics, or are there alternate mathematics we just haven't discovered or invented yet, depending on your point of view?
So to answer that question, I mean, that depends a little bit on whether you regard everything, every branch of mathematics, is that part of the same mathematics? And, we would argue that probably it is. So even if you will start now something entirely new, some people will say, well, yeah, but that's part of the whole of mathematics, of course. But the point I was trying to make about the invention discovery is that humans tend to invent the concepts. The concepts were not there. I mean, we invent them. But then we discover all the connections and relations among those different concepts. So it is not, I think, correct to even ask the question, is mathematics an invention or a discovery? Because it is really a combination of both.
It's a Venn diagram. It's almost, it is really a hybrid. I think the human imagination is great at filling in the gaps in what we know, and that's where the imagination comes in, isn't it?
That's right. So that's part of it. But it is, it is really like a little bit like sometimes in language you also do this, and so on. So just to give you an example, I mean, you could think of prime numbers, okay? These are the numbers that are divisible only by one and by themselves. The concept of prime numbers was an invention. I mean, sure, they are part of the numbers, but to actually single them out as a concept, this was an invention. The fact is that the Chinese actually did not use it that much, and so on. So there are different cultures could come up with different type of concepts. But then, of course, all the theorems about prime numbers are, of course, discoveries, because once the concept was invented, humans did not have any choice as to what the relations between those prime numbers were.
It's like when my favorite batters come up to the plate and hit a home run. Okay, that's one thing, but on-base percentage is kind of an invented statistic. And then once you've got on-base percentage, then you can do on-base percentage with runners in scoring position. It kind of builds on itself.
That's right. So indeed, this is how mathematics has evolved, right? That humans invented new concepts all the time, and in some cases entirely new branches of mathematics. And then, of course, discovered the relations between those concepts and previous concepts, other branches of mathematics, and so on.
But I think one of the points you're making is that maybe it's just a great vanity to think that we have invented all this stuff when in fact we are just discovering what has already been there for the ages.
So this is my point. I mean, once you invent something, then you have no more choice in the matter. I mean, once you say, okay, I invent the concept of axioms in geometry, let's say. So the fact that there should be axioms is an invention. I mean, you could do your mathematics without relying on that very particular concept. But once you invented the concept of axioms and you formulated them, what comes out of those are discoveries, because you then no longer control what comes out.
You've spent so much time, you've written about the golden ratio, you've talked about the equation that couldn't be, the problem couldn't be solved. This is more than just an academic exercise for you, I gather. I think you're looking for the answers too.
Oh, absolutely. Look, I mean, I'm a theoretical astrophysicist, so at some level all my life what I've been doing is using mathematics to explain the universe. So I've always been aware of this problem. Furthermore, I was aware of the fact that Nobel laureate Eugene Wigner, wrote this famous article called The Unreasonable Effectiveness of Mathematics. It always intrigued me. But until now, I didn't find the time to actually sit and really think about this very seriously. And now that I did, I wrote the book.
Well, let me pose to you one of the things that you bring up in the book. If we should start receiving signals from a distant galaxy, a distant planet, maybe another universe, maybe there are multiverses, will we recognize the mathematics that comes through?
The real answer is that I don't know. So we cannot receive, I think, signals from other parts of the multiverse. Those are sort of causally not connected to us. But from other planets we could, and in principle even from planets in other galaxies. Now, because we know that our mathematics was fashioned largely by the way we perceive the universe, the fact that we can see very clearly discrete objects and so on. This partly led to our invention of natural numbers and so on. So as long as we don't know exactly what those creatures are like and what their perception system is like, then I cannot tell you whether we will recognize their mathematics. At the same time, given that they may have emerged also on the surface of a planet, around a sun-like star, and so on, and, we're at some level shaped by the same type of forces that we are, and so on, it is not impossible, or at least not inconceivable, that their mathematics, even though maybe their notation is different and other things like that, but that the concepts of their mathematics may not be that different from ours. So then we may be able to recognize it.
Maybe that would lead us to a kind of language understanding at some level, because language is a mathematical construct too, is it not?
In many ways, yes, it has. Language has many concepts like stimulus freedom and open-endedness, which are concepts that also characterize mathematics. The fact that I can tell you a sentence now that you never heard before, and yet you can understand it. That's one of the things that also characterizes mathematics. So. That's right. So in that sense, mathematics could serve as some sort of a language to begin with these other civilizations. But as I said, it's possible that, the way they transmit that or the way that they choose to represent their mathematics will be such that maybe we still don't understand it, even though maybe we see some regularities that wouldn't be there if it was just some natural phenomenon.
Let me tell you, one of the things that struck me in your book was there was a paragraph near the beginning of the book in which you said, some people say, all right, is mathematics an invention? Is mathematics a discovery? Who really cares? But then you substitute God for mathematics. And suddenly the question is God an invention or is God a discovery? Now you've put a whole different spin on this, and it takes on a much greater gravity.
Yeah, I was trying to be provocative there. Because some people who are not interested in mathematics, may say, but who cares if, it is an invention or a discovery? But to somebody like me, who understands what powers mathematics has, to describe the universe, it is a little bit of the same type of powers that people normally associate with a deity, that it's everywhere and, it's omnipotent, and things like that and so on. So I said, well, would you not have cared if somebody asked you the question, is God an invention of the human mind or a discovery? And of course, most people would say they care about that, where to me, the question of whether mathematics is an invention or discovery has a similar type of importance. I would not try to rank them, one against the other, but it is, I wanted to give the flavor of that. The question is very important.
There was one review of your book that I read that was generally very, very complimentary to the book, but expressed a little bit of frustration that you hadn't come up with pat answers by the end. Apparently, they didn't reach the very last page in which you quote Bertrand Russell as saying, the point is less can we find the answers than let's have fun asking the questions.
I agree with that. That review was generally very good, but I was also a bit frustrated by the fact that I actually worked very hard to explain that the answer is not black or white. I, as I explained to you now, it's a combination really of inventions and discoveries. That particular reviewer seemed to have been disappointed by the fact that I couldn't come up with a definitive thing saying it's an invention or discovery. And you're also right that Bertrand Russell, talked about philosophy in general. and explained that the questions are at some level more important than the answers. And this is the way I feel about the book too.
It elevates us. I mean, I'll be honest. I wasn't a very good mathematician when I was in school. I felt so much smarter by the time I'd reached the end of your book.
Well, I'm very happy that you say that. I mean, of course, my book is not, there are no mathematical formulae and so on. It is really about ideas about mathematics. And in that sense, it does fall in the same category as philosophy, where it is the search, that enlarges and expands your, visions of what's possible and in your mind and so on, irrespective of whether at the end you have a yes or no answer.
I almost didn't matter. It almost didn't matter to me by the end that I had no yes or no answer. The journey is what was worthwhile.
Yes, well, I agree with you. And also, I feel that I did give an answer, only that this particular question, it's not a yes or no answer. It's more complicated than this. There was one thing that we touched upon, which was this business of, was our mathematics somehow inevitable? Mm-hmm. And I feel that it's not necessarily the case that our particular brand of mathematics was inevitable. I mentioned the fact that had there been maybe something like an isolated jellyfish at the bottom of the Pacific Ocean, where it can only feel motion and temperature and pressure, if that was the intelligent creature of the universe, it might have not invented the natural numbers. So yes, I don't know that our mathematics was necessarily inevitable.
Mario Livio is 78 now and is continuing his work on the emergence of life in the universe. Now you can get a copy of Is God a Mathematician by Mario Livio by tapping the link in our show notes or by going to our website, heardeverything.com. We may earn an Amazon commission if you make a purchase. Heardeverything.com is where you'll also find my 2000 interview with Neil deGrasse Tyson.
Science literacy, in the era in which we live, the last thing we need is a scientifically illiterate public because there are too many issues, too many problems, too many things you're going to have to vote on.
And my 1994 conversation with Carl Sagan.
The long-term future of the human species requires us to be in space, not for impractical reasons, but for the most practical reasons imaginable to safeguard the future of our species.
And of course, we post new episodes every Monday, Wednesday, and Friday. And you can find Now I've Heard Everything everywhere you listen to podcasts. And thank you so much for listening. Next time on Now I've Heard Everything, he's an author best known for his suspenseful political thrillers, but a few years ago, he wrote a different kind of book, a book perfect for this time of year, actually. My 2002 interview with David Baldacci about his book, The Christmas Train.
There are enough writers out there writing the same book over and over again, 2, 3, 4 books a year. I don't want to do that. That's not why I got to be a writer. I make a great living, but I want to write books that each of them are fresh, each of them have originality.
That's next time on Now I've Heard Everything. I'm Bill Thompson.